Okay, awesome. Looks like we're live. Yes, basically, welcome to Advanced Git Talk, how to survive in the forest of Git. Okay,
Forest.
awesome. Anyway,
Looks like we're live.
My name is Arti. I've been doing
basically
this software thing for
welcome to
a bit over 10 years.
Advanced
Git Talk.
I have
contributed to the
in
Git project itself, so
forest of
I know a little bit what I'm talking about.
Okay,
Forest.
awesome.
And
Anyway,
looks like
I'm,
we're live.
my name
is
embedded software
Arti.
engineer at Sparkle.
I've been doing
basically
this software thing for
welcome to
a bit over 10 years.
Advanced
Git Talk.
I have
contributed
we're
to
gonna
the
talk
project
about
itself, so I know a little
why
bit
Git
what I'm
is
talking
actually
about.
really
Okay,
simple.
awesome.
Anyway,
looks like we're live.
my name is embedded software
Arti.
engineer at Sparkle.
I've been doing
basically
this
software
software
internals.
welcome to
bit over
10 years.
Advanced
Git Talk.
Contributed
We're going to talk about
project
itself
itself,
first.
and
I know
from
the
there
why
to
Git
be
is actually really
Okay,
simple.
awesome.
Anyway,
looks like we're live. My name is embedded software
Arti.
engineer at Sparkle.
I've been doing
basically
software
internals.
welcome to
over 10 years.
Advanced Git Talk.
Contributed
We're going to talk about
project
itself
itself,
first.
and
I know
from
the
there
why
to
Git
be
is actually really
Okay,
simple.
awesome.
Anyway,
looks like we're live. My name is embedded software engineer at Sparkle.
I've been doing
basically
software
internals.
welcome to
over 10 years.
Advanced Git Talk.
Contributed
We're going to talk about
project
itself
itself,
first.
and
I know
from
the
there
why
to be
Git is actually really
Okay,
simple.
awesome.
Anyway,
looks like we're live. My name is embedded software
Arti.
engineer at Sparkle.
I've been doing
basically
software internals. Welcome to. You forgot to mute the stream. Okay, very good that we have people that are checking on it. Yeah, basically that is the agenda. This talk is, I assume that everyone who is watching this talk already has played around a bit with Git, knows that you can git add, git commit, and git push. I hope. Also, if anyone has any questions, ask in the room right away. Raise your hands, wave at me or something. And if there's anything in the YouTube chat, then I'm also happy to answer. Also, the link to the slides is arti.e/git, so you can see the slides for yourself. You have a question?
Yeah, is it possible to remove a commit in the middle of history?
Easily. Easily.
Rebase.
Yes, that's called rebase, and I will talk about it in the second half of the talk. I will show some demos, hopefully. Hopefully those demos will work. If they don't, then we will learn how to fix Git even more. Yeah, I guess let's keep going. So if any of you have ever opened the manual page for Git, the first sentence says it's a stupid content tracker. No one has done that. No one never reads the manual, so I don't expect it. Yeah. But basically, Git internally is just a bunch of objects that are pointing at each other. And there are basically 3 different objects. The blobs that contain file contents, the trees that contain the file names, and commits that just point at trees that record what has changed. And then you have tags that are not really relevant unless you're doing code releases or releasing new versions of your software. The database that contains everything inside the Git is basically a key value store. So there's a huge folder. There's a huge folder under git.git that just has a hash of the whatever value you're storing there, and the value itself is in the files. So it's just a bunch of files in a folder. And all the objects in the database are immutable. So unless you basically each change creates new object inside of it. On the right side, I have few demos. Basically, we can let's go through with them. Okay, presentation, and let's create a new directory for the test. Okay. Okay, cool. I think it's readable. Pretty good. Okay, I hope. If I can make it a bit smaller even. Okay, still good. So basically, when you create a new empty Git directory and you do tree.a, there are basically the only thing that happens is that you have the Git folder and some files inside of it. And the database itself is in the objects directory. Currently, the folder itself is empty because we haven't saved anything inside of it. Yeah. Basically, and from there, as I said before, the file contents and the file names are in a separate objects. That means that if you have two files that are identical, for example, in this, I can't copy from here. That's unfortunate. If you create the files, and I have to probably bring up the terminal because it's not visible on the. Yeah, okay, that's much better. So when I have those two files that are the same, I can just see that both are saying hello world. And if I do the git add, and now those files are actually recorded already inside the Git object database. But because the contents of both files is identical, then we only have a single file in there. So if I do the find objects type files, we only have a single one in there. And you can see that this is just a hash of the file contents that we have there. Every object also has a little header that says that what type of the object is there. And if I do that demo code in here, you can see that if you just hash this string, you get the exact same hash as it's recorded in the database. So that's pretty much it. And you can obviously read the file and by the hash. Not object. Okay. Well. Okay. I have a typo in there. Okay, now it works. Other thing is that if you actually run those same commands in your own computer, you will get exactly the same hash. So it doesn't record any of the file names, any of the dates or times or whatever the metadata of the file is. Nothing is stored in the blob. The file names and file other attributes are stored in the tree objects that are next to the files. By doing that, one thing that happens is that each time you change the file, you create a totally new object that contains the new copy of the file. So basically, each change is a copy of the copy of the copy of the file. That was basically the joke in the title screen. That's how the internal Git model works. Everything is a copy of the little changes.
So basically, all files are stored completely, not just changes.
Yeah, exactly. There are no deltas stored. Everything is like full files. So if you have like large image files or some other blobs that they're storing, then Git doesn't work really well. But if you store text files, then it works pretty well. The reason is that by default, the object files are separate, but when you send those files to the server or to other people, then Git actually packs all those individual objects into a single file and compresses that. So in that case, it can store it as a like a delta compression, but that's still like a separate layer from the database itself. Yeah, question?
Regards size of file, for instance, if I would like to keep images in Git, is there any suggestion regards size of file?
As long as you add it once and never change it, it's fine. But the problem is that if you change the image file, it will create, for example, if the image file is like 1 megabyte, you change the byte in there, you get two objects that are 1 megabytes, in total 2 megabytes, but it's like expands quite large if you do that. So if the image file is only added once, then it's fine. You probably have to think a bit ahead if you really need to have like 1 megabyte image file for your static homepage in there, because you probably, the browser will scale it down. So it will make sense to downscale the images also before adding them to the Git. But if you still want to work with large files and Git, then there's separate add-ons. There is a Git annex that only stores the tree part of the file inside Git, and the blob itself is separate. And then there is a large file support in Git that also does something similar, but a bit differently. But yeah, there are workarounds, but they're not really pretty. They have their own problems.
This is Git LFS.
Oh yeah, LFS, yeah. That's the short name for it. Git large files, LFS. But yeah, because as long as the files don't change much or at all, you can reuse the same object. So as you saw in the demo or in the right side, two files with identical content are the same object basically. From there, when you actually do a commit, it will store the file names, and each tree contains the file name and the hash of the file contents. So if you don't change anything, it will stay the same, but if anything changes, then it will also change. And from there, commit itself is just a pointer to the tree, and that's pretty much it. And because everything is immutable, you can always be sure that whatever you put in, you get out also, if you use the same commit or same hash. Yep. And from there, we get to the branches and tags that are basically just a file that contains a string with the hash, and that's it. Just a file name in the Git folder. And that also brings to the point that it's pretty much free to add as many branches or tags or what you want. There's no overhead for that. Because it's just files in a directory. I think we can, if no more questions, we can go forward, and that's how Git works. Welcome to the talk. Because the internals are really simple. Question?
Yeah, can you go into a bit more detail about the head?
What? Head. Okay. Git head is a kind of special pointer. It always points to the currently checked out branch or commit.
So the one that you have in the working directory?
Yeah, exactly. You can have several heads, and there are actually, because you can, the single .git repository can have several checkouts into different folders.
So okay.
Yeah, so the head itself is the default one. So if I, let's commit this file here, and now we have a pointer in Git head that points to the refs head master file. We can cat that. We have to add .git. We get this commit hash, and if we do git show, then we will also see that the file, the commit hash itself is the same as where the fuck you do? Yeah, okay. So yeah, the master branch itself currently points to this commit, and that's the commit hash. And if we cat that cat file and print, we get pointer to the tree, and tree itself points to the blobs that we created previously. Because we have two files, but they're the same content, we get same hash, but different file names. Yep. Any more question? Yeah?
Yeah, I have a specific situation. For example, I made like 20 commits in my repository, and from 5th till like 15th, I saved some key, a password, and I would like to just remove this password from those commits.
Hopefully you didn't push it to the server yet.
No, I didn't, of course.
Because then it's a bit more complicated. But if it's still locally, then you can first you have to edit those individual commits that contain all the commits that contain this key, because each commit can point to the same like the file contents. So if you have several commits that contain the same file, then you have to change all of those commits to point some other file. For that you have to use git rebase. Yeah, I guess we can go forward. Now the hard part, that's actually manipulating this really simple database and making the lives easier or harder or something in the between. The heart of everything you do with the Git is a thing called the diff. And if you do merges or want to just see what the changes are between branches or commits themselves, then Git internally will invoke the diff command. Git also has like internal diff implementations, but it's pretty much the same thing. Diff is implements an algorithm written in the 70s for the original Unix machines, and specifically it works for the it was written for the ed text editor. That was one of the first text editors for Unix, and ed itself was a line-based, so diff also works in lines, and as long as your changes are contained in a single line and some other changes are separate lines, or then you usually don't have any merge conflicts, because diff can figure out usually what you're trying to do. There are edge cases. If the line changes are too close together, then you will break everything, but then it's like unambiguous anyway what you're trying to do. And the motto for Git is that it will only do things automatically that it can be 100% be sure what you meant. If it's not sure what you're trying to do, then it will error out, and you have to figure it out yourself. So basically, if you how to keep those merges and changes and whatever you're trying to do painless is that you have to fix those conflicts early. So that means you have to, at least I recommend to do rebase often. That means rebase means that you take your changes that you have and move them on top of the master branch or main branch, or what your the underlying branch is what you want to do.
What do you mean on top?
I'm gonna
Actually in the file on top, no.
basically the commits themselves. The rebase manual actually has a pretty good diagram. What it means that you take your few commits that are behind from the master branch and you move them so that the parent of those branches is the latest master. And during this change, you will have to figure out all those merge conflicts and errors that can happen to the changes that others have done. And because you hopefully wrote that code quite recently, you still remember what you wrote and what you wanted to do. So it's better to do them early in the process or continuously while you're developing your code. And yeah, question?
What's the difference between a merge and a rebase?
In this context, not much. The thing is that merge will just glue two different branches together so that you have a somewhat unified view of what's going on. But rebase will graft your changes on top of it. Yeah, that probably I should have written it out a bit better. Hopefully it answered somewhat, not really probably.
I guess it's the difference somewhere that you in merge you will have additional like commit.
Yeah, that's also one thing that merge commit has several parents that are merged together. Okay, but going back to this, one thing is that if you do git pull when okay, lost my train of thought right now. Yeah, okay. Basically, if you do a git pull, by default it will try to merge the remote server changes to your on top of with your current changes. But the problem with that is that first you obviously have a pretty ugly git commit history, and the other thing is that if you later try to fix up your commit history for fixing up the ugly commit messages or try to make it more presentable for code review, or just want to fix some typos that you found later, then doing a rebase over the merge commit will break things. For me, at least, I have never managed to figure that out, how to do proper rebases over a merge. For some reason, it breaks always. But if you keep your code lines short, and if you have, it's better to organize your project to have several smaller files than larger ones, then you also have less conflicts between people developing. And if you do large reformats, then you have to minimize those into usually a single commit or like separate from all the other changes. In that case, it's much easier to rebase or review codes, or let's just see that, okay, this line change was part of only the reformat and it doesn't do any functional changes. And if possible, just only reformat the lines that actually you're changing. Usually it's a bad idea to reformat the whole file even if you only want to change like one line in there. I know that some IDEs do it automatically each time you open the file. I think it's stupid. Try to disable it. But if you do have merge conflicts, I hope all of you have found that there are tools that help you out. So always try to configure. There is a Git command called a merge tool, Git merge tool, that will launch the configure tool to fix the merge conflicts. And by default, it's Vim. Vim is cool, but I don't know how to use Vim that well. So I usually set it to Meld or kdiff3. Both are pretty good. Meld is only on Linux, but kdiff3 is also available under Windows and other platforms quite easily. And you can usually just use the git config command to change it. Using a GUI makes your life much easier, because then you can select like which side of the changes you want to have, and maybe also add extra changes in there, but hopefully not, because then it will be hard to understand what's going on. And after the merge is done, then it's a good idea always check like what you actually committed, because sometimes if you have really confusing codes on both sides, it's really hard to see what the heck happened now. And I have seen people commit really interesting changes into the Git repository after doing a rebase. Yep. And from now we get to the rewriting history part. Usually when you develop code, you don't get the changes correct on the first try. You probably try stuff, you find some bugs, you fix them, you commit more fixed type of commits, and do lots of stupid stuff that you probably don't want to end up in the history, because it doesn't give any value to the code reviewer or in the project lifetime even, because you probably changed it in the next commit already. But it doesn't matter. It doesn't still excuse that you shouldn't try to at least build as good Git commits in the first try as possible, because later it's easier to fix stuff up if you have good commits already in there. One thing that I have seen that helps quite a lot is to commit changes in a single file in separate commits. So you can split up the file into. I'm going to do a demo. It probably shows better. So I think I have this hello here. Okay, I'm going to do that. Where is the text editor? Here. So I have this file called hello world, and if I add some changes to this line and lines here, and from here, if I can use the command line way of doing git add ---- patch, but because I'm a sucker for GUIs, I usually use either the built-in GUI for the Git called Git GUI. It's literally called that. And you get this little pretty window where you can select that I want to only add this bottom line here. So I can, where is this? Add line. Stage line for commit. So right now I can do a commit that only adds this bottom line here. But the exclamation mark in here and the new line will not be added, so that I can do a separate commit message. And I can do a commit, and now I can do bad commit message examples. I think. Right, I have to also stage it, and now I can stage the whole file if I can. Okay, we usually don't use that GUI, so I can use the other one. The better one. The GNOME, okay, I'll make it a bit smaller. GNOME desktop has really pretty GUI GUI called the git.g that is a GNOME Git client, but it allows also the same thing that you can select the lines that you want to add. If I can make the window smaller, yes. I can make it in bigger, but yeah, I can just select, for example, only add this single new line here. And okay, but this time I'm gonna just stage everything and I can do the commit. Bad commit message. Yes. And if I do git show, I can see that the last commit only added the new line and the exclamation mark. And if I do the git log, then I can actually see that. And at the bottom line, I can git show that. And the previous commit only added the single line. So this way, it's possible to separate out your changes into logical commits. So if you just fix some typo in somewhere that is irrelevant to the current feature I'm working on, then you can just separate it out. It will later, if someone is doing code review, then it's easier to just skip that part because it's probably boring. And you can keep the code reviewer focused on only the features that you want them to look at. Other thing is that everyone should use right now, or at least start using, is git commit amend. That allows you to fix the last commit that you have already committed. So you did some typo, then let's do them also. Okay, lines here, but I want to remove this new line here because it's stupid. Where is the terminal? Here. And if I do the git status, it will show me that, and git diff shows that I want to remove this line. Current commit that I have adds this line, but I don't want it here. So I can do git add my file because I want to add everything. And now I can do git commit amend. It will show me the last commit message that I wrote. I can change it here. Probably should. Let's delete this line and write something better. Commit message. And I can. Okay. Yes. And now if I show the last commit, it will show that the message has changed and also the new line is no longer here like it was previously here. So I have fixed my bug or typo or whatever I had in there. But this only works for the last commit that you made. For anything else, you have to use interactive rebase. That is a big kind of worms on itself. So, as you were, okay, you have a question?
If I push to server changes, then is it fine to use amend as well?
No, it will create a new commit and it will conflict with the server. So you have to force push it. If you're working in your own branch, it's usually okay to just force push your own branch. But if you're force pushing it to the master, then other members of your team will get really angry at you because it will break their own Git repositories. Obviously, everything is you have to just communicate everything. So if you talk to your teammates and you want to force push to master, then just verbally say that I'm going to break your Git now. Be ready to Git reset hard on top of master your own.
But maybe just better override.
Yeah, it's better, yeah, not to do that and do it in your own computer or on your own branch. As long as you don't push, you can do whatever you want in your own computer because the Git always has the whole history with you. So you can do whatever you want, experiments, stupid hacks, everything is allowed. With the interactive rebase, you can change much more than just a last commit. One thing that I recommend to do is to create a tag or a branch from the current state that your repository is in, because that gives you a really good way to go back to it if you mess up or break something. So I think I have a demo somewhere here. Git 4, I think. Yeah. So I'm going to open my awesome branch here. Okay, can I make it bigger? Probably not. Probably not. Okay, then it's going to be a bit tiny. But I have a few commits here that probably shouldn't be there. I was trying to do something, but now that I figured out how everything works or how the code should look, I can just see that it begins from, okay, let me try that. Yeah, so first thing is that I want to move myself probably on top of the master, because master has a update build depth commit, but my branch doesn't have that. So I probably also want to first rebase on top of that so that my commits are there. We can do that by git rebase master. And now if I open up the, I was on the wrong branch. Cool. Check out, check. Feature. What? Yeah, okay. Now it's correct. Yeah, now I'm in a correct branch. And from now I can do git rebase master. Yeah, okay. So now that changed was that the build depth commit is inside my branch now. So I'm up to date with the master. And from here I can go and do a fix up of everything else that I have there. For that, I can use the git rebase interactive, and my original commit where I want to start is actually the master branch. And now it gives me all the commits that I have here. How the Git works, Git rebase works is that the commit messages here are reversed, and rebase itself starts running the commands from top to bottom. By default, every commit is picked. That means it just will use the commit as it is. It doesn't change them, except it will change the timestamp and will actually generate new commit messages. But functionally, nothing really changes. And if you follow the rules that every commit is as small as possible and only contains functional changes, then it's quite easy in here to fix your stuff or reorder the commits afterwards. So for example, in my case, I know that those fix commits, I can just select everything, delete them, and insert fix up to all of them. So now when I did that, every commit here will be merged with the very first commit and will be deleted by itself. So when I run this, or actually save this file and exit Vim, it will show that everything was successfully rebased. And if I check the commit history, we can see that there's only a single commit left now. All the mistakes were erased and merged into a single commit. And this will also fix the problem that in some later commit you added your private keys in here. And actually it will not fix it because we just merged them. But if instead of fix up we would have deleted the line itself, that would have probably broken something else because every commit is a full view of the drop. Drop. Okay. So yeah, there was a hint in there. So there are options. Probably that we didn't delete the private keys yet though. But now that we only have the single commit left, we can do a edit for that commit and actually change or split out that commit into separate commits that are easier to review or delete private keys from there or do whatever we like. So the command itself is the same, just rebase from master, but instead of pick we can do edit. Yeah, there's a drop here. It will just remove the commit, but because the later commits will still contain the key, it will be still there. You sure?
Pretty sure.
Probably. Okay.
It might stay in the objects folder though.
Okay. Yeah.
It's not going to be in the commit history because Git actually.
If it's a separate file, then it's probably fine.
Yeah, because Git works under the hood. It doesn't do that, but functionally it works with delta. So if you remove an addition of a file, the addition of a file will not exist and follow all commits.
Okay. Yeah, that's probably true.
And that's why it will recalculate all of the hashes for all of the commits as well.
Okay. Yeah, that sounds right.
But if it's in the Git objects, then.
Oh yeah, the Git objects folder is never deleted, or actually it is deleted, but it's like only every 60 days is the garbage collector that runs. It depends. There are some heuristics in there, but yeah, there is a garbage collector that eventually cleans up all the mess that you have left behind, but it will take a bit of time. So right now I did a rebase edit of the commit and it dropped me into a nice little prompt where I can just do whatever. If I do git status, it will show me that I have I'm currently in the edit phase of this commit, and if I do git show, it will show me that the latest commit was my important feature. And now I can do more commits in here. I'm gonna first change the existing one with amend because it's the last commit, so you can use just git amend to change it. That's quite easy. Let's allow empty because I don't actually have any code in here. And messages. Changed commit message. So, and let's add another one. And now I can do git rebase continue. And if I check the history, it broke everything. That was not supposed to happen. Looks like I broke something. It should have worked. Interesting. Let's edit again. It might be that because I don't have any commits here, it will do something stupid. Let's try to amend and allow empty. Things. Okay. And okay, I forgot to remove amend from the last commit. That's why it didn't work. Another commit. Now it will work. And rebase continue. And now I have actually 2 commits here. That's what I actually wanted. But to actually split up the commit, you can't use amend. So for that, I'm gonna edit this first commit again. You have to use git reset, and you have to reset to a reset head git.git/head pointer to a previous commit before that, or actually the current branch that you are on. So for that, you just usually use. There's a huge man page that shows all the ways you can reference previous commits, but I usually just use the head tilde, I think, a number of commits you want to go back. So in my case, I want to go back 1. And now if I do git show, it will show me that I'm in the last commit that was in the build tabs, but because I didn't add any more options here, all the file changes are still here. So right now I can do git add, patch, or use the fancy GUI to split up the single changes into different commits.
Git status.
Git status will show me that there is nothing to commit, because that was actually pretty bad demo. And yep. And because I don't have any the original commit anymore, I have to commit, or I will lose this commit. Let's do allow empty and empty. Git rebase continue. And yeah, basically pretty much nothing changed. We're still at those 2 commits, but yeah. So yeah, and I didn't do that, but then you can, after you're done your git rebase shenanigans, you can just delete those tag checkpoints that you made, or maybe didn't make them. The git tags and branches are free, so, and they're just files and that point to git commit hashes, so you can use as many of them as you want for any purpose you might want to use them. And so yeah, they're really useful. Use them a lot. Also use descriptive names. That's great. Test 1, 2, 3, 4 doesn't really help. But if you still forgot to do a tag your work before doing any operation, then there's also a git reflog. Git reflog is basically a question.
Yes. So branches and tags can have the same names. What's the priority?
That's a good.
For anybody wondering, don't do that. That tends to break things.
Oh, actually, yeah, we had this issue at work where we had the tag and then we had the branch that same name, and apparently there is a priority. So the branch is the tag is selected first, then the branch is selected second, and then there was a third thing actually, but I forgot that. So if you have to actually specify that you are selecting the tag, you use refs tags and the tag name, or refs heads and the branch name.
Maybe tag commit and then hash. If you're maybe using like a hash as a tag.
Yeah, I think it was that.
Yes. Git allows you to shortcut. You don't have to fully specify that you're working with branch names or tag names. You can just say tests or test, and looks like, yeah, and then Git will check, use the tags first before using the branch names. But because Git also allows you to use the fully qualified name, so you can just use the full name under the git refs folder, and it will use the whatever is inside of the file. So you can just, yeah, it will just use the hash, or just use the hash itself if you want. You can, Git is quite lenient that you can specify the commit hash we are a lot of ways, different syntaxes that you can use. Yes, but if you still fucked up something, there's also reflog. And it is a log of where your Git head has been. And also a bit more metadata that shows that what has happened with the Git repository before. You can use reflog to go back to previous state. If you, it will take a bit of guessing to see what's what in here. At least I usually can't on the first glance figure out where the rebase started. There is a rebase start, but I don't know. Sometimes I still manage to fuck up. But it's a pretty good fallback to see where you were before, and yeah, sometimes helps. Obviously, the last option is just nuke the whole folder and clone it again. That also always works, but if you have a big project, then it will take forever to download the repository. Especially, yeah, like for example, Linux kernel is pretty big. It's 1.5 gigabytes. It takes time. So with bigger projects, you probably don't want to do that. But yeah, reflog is good. You get the commit hashes here and also the shortcuts that says that how many reflog lines you want to go back. Yeah. And you have to remember that this is not forever. Each time Git garbage collector runs, it will remove the objects that this reflog is pointing at. So you can't go back infinitely, but today's and yesterday's commits usually are still there. After that, who knows? Yeah. Also, some other tips that I've acquired during the years. Write good commit messages, please. Commit message starts with a title that says what will happen if you apply this commit, or if this commit is merged, or like what will happen in the future if this commit is used. Yeah, question?
Not exactly. I just want to point out that when you write this git commit -n, you can actually add multiple -n arguments, and they end up on each separate line.
Huh, that I did not know. Okay, that's cool. Probably using a text editor is nicer. Vim by default actually also will, at least NeoVim will highlight if you go over the line lengths and forget to do stuff in there, and will highlight the commits in there, comments. But yeah, commit starts with title, then there's an empty line, and then you have the description why this commit even has to exist. It describes the reason for existing. The change itself is in the commit itself, in the diff that Git will show, but why it changes, why this change is made, this is the important part. And hopefully, maybe if you are using some internal bug tracker or Jira or whatever you like, then probably some trailer codes or tags that point to the issue that you fixed, link to the issue tracker or some other metadata. So probably one, yeah, question, yeah?
How much time do you spend on, because of course everyone says make good commit messages, but how much time do you spend on the messages?
Depends. If it's
Compared to the time you spend coding, let's say.
little. Compared to the coding time, quite little, but it's still, I think, depends on how big the feature or how much code I have written. But usually like 5-10 minutes.
Quite often, if you wouldn't write it in the commit, you would end up writing it in the pull request comments anyway. So it's probably a good idea to have it in the commit in the first place.
Yeah.
Usually my pull request comments are just like see commit message for details.
Yeah, that's yeah. Here's a good one I wrote for the one single commit I managed to get into the Git project itself. That says that it has a title, what it's gonna do, and why it's gonna exist, why this commit has to exist, what it will do. And some trailers that say that yeah, this commit was looked at by those people. Yeah, question?
What is your opinion about squash after approve merge request?
That's organization specific. If people in your team can't write good commit messages, then it's a good idea. But if the commit messages themselves contain actually good information, then don't do it. I know that some people really like to remove everything.
There's also this annoying issue that whenever those commits are squashed together, and if they contain commits by the other people, then basically the merger gets the ownership.
Yeah, there's also that. So
this information.
that's also a thing. Yeah, the blame will get wrong. I haven't seen it happen in like private companies because in that case you just write your code yourself and push it, and someone else just presses the merge and that's it. But in open source projects, it's quite common to to merge someone else's code in or change small things in it or add something and then merge it. So in that case, it will be a bigger problem. But yeah, I try to write good commit messages. Obviously, it always doesn't work. Sometimes it works better than others, but try to write good ones. Because it will help you to figure out what you actually wrote. Was it any good? It will help the code reviewer to figure out what you're trying to do, and it will help you in the future when you don't remember what you wrote to figure out why you wrote that code. That's the classic meme of Git blame of what is this shitty code, and you see that you wrote it 6 months ago. And the commit message says fix bug, and you don't know why. But if you wrote a good commit message, then you can at least see that what was the reason for it, for writing that shitty code. Other things, when you git push after doing a git rebase, all the commits will be different, and the Git server will scream at you for trying to push things that are not valid. But there is an option called git push force that will just override anything in the server. For some reason, Git has an even bigger option called force with lease that first checks that server has not been updated. That your local reference to the server's local reference to the server branch is the same that the servers think it is. And if it is, then it will force push over it. This will break down if you're using IntelliJ IDEs, because IntelliJ will, behind the scenes, every 30 seconds, git fetch the latest branch information from the server. So in that case, force with lease will not work, because it will always think that you have the latest commits in your own in your local repository. But if you don't use any fancy IDEs, then it works great. Also, Git submodules are hell. Don't use them if you can. it's horrible.
I'd like to specify Git submodules are actually perfectly fine and they work fantastically, except nobody's workflow matches how Git submodules work, and I don't think anybody's workflow ever will match how Git submodules work.
Yeah, just horrible. Don't even. Git mono repositories are much better than submodules. Just copy everything into a single repository and deal with the consequences later when it's 20 gigs large or whatever.
What about the Git large file support?
Also don't use that because it's not really a Git anymore. It's glorified S3 bucket with Git frontend. As long as you are using a single server and never ever plan to migrate to a different server or provider, it's fine. But as soon as you have to move your Git repository from GitLab to GitHub or vice versa, or into Git bucket or Git thing, all the links to the large files inside the commit messages or the trees will point to the old server only. So you have to rewrite your whole repository if you migrate. It's pain. Don't do it. Also, the manual is really good. The Git book is really good. Read it if you have time. And also the manual, the man pages themselves are pretty good. I have a few more links, but the slide was getting full. Also, the command line Git is okay nowadays, but still using the GUI tools usually it gives a better overview of what's going on. It depends on the tool. Like as you saw, I was using the GitGA or the GNOME Git thing. Question?
There's one good tool that's actually not in the list. It's Tango in the Git backwards. It's N versus console in Git.
Right. I
It's
see.
package management, but they didn't go around.
Do they have a pretty
Not the screenshots.
screenshots?
Just install it.
There's also a possibility that I already have it. No, I don't. Oh, it's 200 kilobytes. Pretty good. Ah, okay. That's pretty nice.
It actually has all those reflog and slash support as well, like the slash and the reflog. Just with them private. Just move.
What do we have? Ah, reflog. Reflog. Ah.
Basically select the commit and then you can, it opens the subcommits under there.
Ah, okay. Oh, okay, that's really nice. Okay, that's a good tool. I'm gonna steal that one.
Maybe not.
Teague is a good one. Okay. First thing, Git itself comes with GUI tools. They're okay-ish. You saw me use the Git GUI to do a commit. There is also Git-K that will show the commits in the history of commits in a different way. So you can see and click, and it's not that good, but it exists. Then there's also IDEs themselves have pretty good Git integration. I know that IntelliJ or JetBrains IDEs have pretty good one, but they're kind of weird also. For example, the git add command to stage your changes. In IntelliJ, it's a separate internal to the IDE thing. It doesn't integrate with the Git at all. So if you stage something inside the IDE, it will not show up in the command line for reasons. Visual Studio Code also has something. I have never tried it, so I don't know. Also, I have forgotten to add Git Kraken. That has really good rebase GUI in it that allows you to drag and drop the commits and edit them. So if you want to spend money, get Git Kraken or get your employer to buy you Git Kraken license because it is really good. Also, I don't use it, but all of my teammates use it, so it must be good. Let me see if I can see the rebase UI somewhere here because it looked really nice. Where is it? Rebase. Interactive rebase editor. Yeah. Basically, you can. It's probably not visible at all, but yeah, you can drag and drop and squash and edit your commits, and they are actually in the same order as you usually see in the Git history. So that's also great. Yep. What else do we have here? I managed to close my slides. No, I didn't. Okay. Yes. Any more questions? Yes, ask.
We actually have 2 questions from the live stream. First is, can you please discuss Git tagging? And in parentheses, it's a DevOps release engineer asking it, so maybe from that perspective.
Okay. Basically, I think I am wrong person to answer that. I haven't done that well. As my Git tagging experience is limited to just tagging the releases of software. So from basically just add a version number to it and upload some artifacts to GitHub release tab. Other than that, and also tag some other experiments in my own computer. Other than that, I haven't used them much. But you can abuse them for quite a lot of different things because they're free. You can do whatever with them. Yeah, and there was another question.
Yeah. Can you discuss your favorite Git interview questions, preferably with answers?
Somehow I have managed to go to the job interviews where they have assumed that I know enough Git that they have never asked any Git questions. So I don't know what they ask. Any of you know what might be some Git trivia questions that I might ask? Because
How does Git compare to the blockchain?
Git and blockchain, how do they compare? Same thing, I think, pretty much. Just one is with marketable names and other is a slang word in UK, if I remember correctly.
Well, and you can rewrite the entire Git history without any massive recomputation, so that.
Oh yeah, that's also great.
Not always. If you are using signed commits, then.
Oh yeah,
it's-
yeah. Then you have to break RSA or whatever the
Sure.
key where you're using with the OpenBGP card that you proudly own, or maybe not. Hopefully not. Don't use BGP. Any more? Okay. Yeah.
What do you think about trunk-based development?
Trunk-based development. I think it's a bit irresponsible. It doesn't matter how good your test suite is. Someone still should review or at least look at the code before you push it out. It can work. I know that you do it and you love it. But I wouldn't trust it much, especially because then you get a lot of garbage into your commit history, and it's pretty bad times to figure out if when something is broken and like who's responsible for it or why that change was made. Especially because you don't have that opportunity to rewrite the history if you do the trunk-based development. You can just push more commits that fix previous commits, and that's pretty much it.
Merge for.
Or you just have a lot of merge, because everyone does the default git pull, and then you have a lot of git pushing of merges. It's not pretty. It works. I don't know. I don't like it, but everyone has their own opinion, I guess.
You can use it in a completely different manner as well. You can still do code reviews and everything.
Yeah,
without a develop branch, basically.
Yeah, I know. My girlfriend uses similar thing. Basically, they push to master, and after that is done, they have a separate service where you push the commits that you pushed, and from there you can give feedback.
Just have feature branches and do pull requests to master.
Well,
and tag stable versions.
Well, yeah, that's the reasonable way to do it.
Yeah.
That's if that's not trunk-based development, right?
It's basically the same.
It's debatable. Some people like twist the meaning of trunk-based development, like short-lived branches also kind of counts.
That's fine.
It
Do
depends.
the short-lived branches, because the shorter-lived the branches, the better, because then you have less merge conflicts and less problems, and you still have the opportunity to fix your stupid typo mistakes before you merge them. For me, at least, I think that's the best way. The full Git flow thing, where you have like release branches and some support branches, and like I don't know if you have seen the Git flow thing. That's too much. Can I open the image somewhere here? There's definitely, yeah, okay, that horrible thing. That is too much branching, at least in the server side. You can do that's too much just management and busy work for anyone's good. Basically, I think all you need is a master branch and feature branches, and that's it. Just that works. That is pointless, I think. Okay. More questions? Maybe? Nope. Okay. Nothing from YouTube? Nope. Okay. Thank you for listening, and let's order some pizza.